Hey guys, so last week we took a test, so let's take some time today to go over some of the questions on the test. Question 1 says compared to the graph f of x equals to x squared, the graph of g of x equals to x minus 2 squared plus 3 is the result of translating f of x. So we're going to take g of x and let's decipher what's happening. Remember we had said that inside the parentheses, these are our left and right shifts. Okay, and since it's a minus 2 inside our parentheses, that actually does the opposite of what we think. So this is going to be a shift of right 2 units. Now the other shift happens outside our parentheses, and that is going to be our vertical shift, and that's either going to be up or down. And since this was plus 3, this is going to be an up 3 shift. So we're shifting 2 units right and 3 units up. Answer choice C. Number 2. We had actually decided to skip. Okay. We are also, let's try to do number 3 together. What is the nth term of this sequence? So my first term is -1. And then I go to 3 and 7 and 11. So I notice that my pattern here is going to be plus 4, meaning we have a common difference of 4. Now we're going to use that formula that's given to us, our arithmetic sequence formula, which is an equals to a1 plus n minus 1 times our common difference, and let's just plug in. An equals to -1 plus n minus 1 times positive 4. Multiplication is commutative, so this is the same as 4 times n minus 1. All I did was switch the places of these two. And that gives us answer choice B. Okay, let's see. We can keep on going. In a sequence, the first term is 3 and the common difference is 4. The fifth term of the sequence is blank. So A1 equals to 3. The common difference is 4. Again, we're going to use that arithmetic sequence formula, which is AN equals to A1 plus n minus 1 times our common difference. Let's go ahead and plug in. AN is equal to A1, which is 3, plus n minus 1 times 4. And we don't want the formula this time, we want the fifth term. So n is going to be 5. Let's plug that in. Our fifth term is going to be 3 plus 5 minus 1 times 4. Our fifth term, if we go ahead and plug this into our calculator, we'll end up getting 19. All right, let's try number 5. Find the sixth term of the geometric sequence for which a1 equals to -7. So again, I know it's in the problem, but I always like to write down my information. And r equals to -1 over 3. So this time we are not using the arithmetic sequence formula. We're using the geometric sequence formula, which looks like this. an equals to a1 times r to the n minus 1 power. Again, we don't need to memorize these formulas. We just need to know how to use them. So to find the nth term, let's go ahead and plug in. You take -7 and you multiply by our r, which is -1/3, to the n minus 1 power. And this time we're looking for the sixth term, so n is equal to 6. Let's go ahead and plug in. To find our sixth term, that's -7 times -1/3 to the 6 minus 1 power. We do not want to do this by hand. Let's go ahead and pull out my calculator. So -7 times -1/3, close parentheses, whoops, nope, to the 6 minus 1 power. And I get a crazy decimal. I don't want a crazy decimal, so let me see if I can change that into a fraction. 7 over 243, that is answer choice B. Okay, I'll pull out my calculator when we need it again. Number 6, determine if the following sequence has a common difference or ratio and state what the value is. So my pattern, right? So the first thing I'm going to do is to go from 1 to 3 is plus 2. From 3 to 9 is plus 6. So automatically I know this is not an addition pattern. So it's definitely not arithmetic. Let's see if it's geometric. To go from 1 to 3, we're going to do times 3. To go from 3 to 9, we're going to do times 3. And to go from 9 to 27, we're going to do times 3. So I know my pattern is something to do with 3. Now, we have to determine, is this a common difference or is this a common ratio? Keep in mind that common difference is our adding and subtracting pattern. So it is not a common difference. It is a common ratio. Number 7. Which trinomial is equivalent to this? We talked about how to do this in the calculator. Let's go ahead and take out our calculator again. We're going to go to y equals, and we're going to plug in the original equation, okay? The equation in the problem. So 3x minus 2 squared minus 2 parentheses x minus 1. And then what we're going to do next is we're going to try each of the answer choices. I'm going to start with the first one. So 3x squared minus 2x minus 10. Going to go ahead and press second graph to look at the table. And notice the tables are not the same, right? The y values are not the same. For example, when x is equal to 9, I have 131 and 215. Again, those are not the same, so it's not answer choice A. Let's go back to y equals. Let's clear that. And let's plug in answer choice B. 3x squared minus 2x minus 14. Again, not the same, right? I get 131 and 211. Let's clear answer choice B. Let's put in answer choice C. 3x squared minus 14x plus 10. Again, not the same, so hopefully D will be the same. 3x squared minus 14x plus 14. And look at that. The numbers are the same no matter what the x value is. Our two y's are the same. Okay. What type of function is graphed below? Remember, this is going to be an exponential function, but let's go over each of those. Linear function. I'm just going to draw them here. A linear function looks like a line. So a linear function would look like this. This one was exponential. Square root. A square root function kind of looks almost like an exponential, but it starts off really fast and then it slows down. So it's like almost like half of a sideways parabola. So this would be our square root. And then our quadratic is the parabola-shaped function, the U-shaped function. Okay, so this was B, exponential. Okay, let's take a look at number 9. The graph of the function p of x is represented below. On the same set of axes, sketch this function. Again, this is a shift question, just like we did in one of the earlier questions. Inside our parentheses is plus 4. This means that it's either a left or right shift. We said inside the parentheses is going to be the opposite of what we think. So this is going to be a left 4 shift since that was plus 4. Now outside our parentheses is either going to be an up or down shift. And since this was minus 3, this is the same. This is going to be down 3. So we are shifting each of our points, left 4, down 3. So pick points that are easy to identify. For example, I'm going to start with this point over here. If I move it left 4, 1, 2, 3, 4, and down 3, I now end up right there. Okay, let me get rid of these marks, make it less confusing, so I end up right there. Let's pick another point. Let's do this point now. Left 4, 1, 2, 3, 4, down 3, 1, 2, 3, so we end up right there. Pick another point. Left 4, 1, 2, 3, 4, 1, 2, 3, so now we end up here. And we want to do all the points we can possibly identify. I can do this one. Left 4, 1, 2, 3, 4, down 3. Okay, so those are, whoops. I'm at the tip now. Let's go over. This point we can also shift. Left 4, 1, 2, 3, 4, down 1, 2, 3. And let's see if we can finish this. This point over here, 1, 2, 3, 4, down 1, 2, 3. No. Okay, and this point, 1, 2, 3, 4, 1, 2, 3. When we are done, we should connect all of these points to still form a parabola. Remember, we are just shifting the graph. We are not changing how it looks. We're not making it bigger. We're not making it smaller. All we're doing is we are moving the graph. Okay, let's take a look at number 9. At an office supply store, if a customer purchases fewer than 10 pencils, the cost of each pencil is $1.75. If a customer purchased 10 or more pencils, the cost of each pencil is $1.25. Let C be a function for which C of x is the cost of purchasing x pencils, where x is a whole number. A customer brings 8 pencils to the cashier. The cashier suggests that the total cost to purchase 10 pencils would be less expensive. State whether the cashier is correct or incorrect. Justify your answer. So, let's first find out how much 8 pencils would cost. If I want to buy 8 pencils, we are going to be using this first function, right? Each pencil is going to cost $1.75. So the cost of 8 pencils is going to be $1.75 times 8. This is where our calculator will come in handy. So $1.75 times 8. And I get that the cost of 8 pencils is going to be $14. Let's keep that in mind. Now we want to find the cost of 10 pencils, because the cashier says that 10 pencils is actually going to be cheaper. If I want to find the cost of 10 pencils, we're actually going to be using this second function. Right? Each pencil is going to cost $1.25. So that'll be $1.25 times 10. I do not need a calculator for this one. That gives us $12.50. Once we have this, we need to make sure we state whether the cashier is incorrect or not. In this case, the cashier is correct because 10 pencils cost $12.50, whereas 8 pencils cost $14. So let's just say that the cashier is correct because 10 pencils cost $12.50 and 8 pencils cost $14. All right, a graphing question. Remember to graph this. We need to graph it separately. So I'm going to graph this first function, which is f of x equals to the square root of x minus 1. And this is when x is greater than or equal to 1. So let me go ahead and write down some numbers first. 1, 2, 3, 4. I know these are the numbers bigger than 1. Okay, and now I use my calculator to get the y values. I get the square root of x minus 1. Get second graph. And then, okay, so let's write down what we have. 1 gives us 0. 2 gives us 1. I don't want to use 3 because that's a decimal. I don't want to use 4. 5 gives us 2. And let's put in 10. 10 gives us 3. So that's this first function. Let's do the second function. I want to change the color. It's not letting me. Okay. The second function now is f of x equals to x minus 1. And these are for values where x is less than or equal to negative 1. Okay, so I have negative 1. I want values that are less than that. So negative 2, negative 3, negative 4, negative 5, negative 6. If I go ahead and plug this into my calculator, I will get values. Negative 2, negative 3, negative 4, negative 5, negative 6, negative 7. let us go ahead and graph. As I'm trying to graph this orange function, notice that's a greater than or equal to symbol, so that's a closed circle. Let's go ahead and graph these points. 1, 0, 2, 1, 5, 2, 10, 3. This is a square root function, so it connects like this. Let's go ahead and graph our green function. -1, -2. -2, -3, -3, -4, -4, -5, -5, -6, -6, -7. Okay, and it's going to connect like that. So this was a piecewise function. All right, almost there. Number 11, evaluate the following functions. So this was the one where, since we had two functions, you had to decide which one you're going to use. I'm going to use two symbols, the star and the heart. We use f of x equals to x plus 5, which is my star function, when x is less than or equal to 3. And then we use 2x minus 1 when x is greater than 3. So let's first find f of 5. So in this case, x is equal to 5, and 5 is greater than 3, which means that we should be using the heart function. Okay, so we should be using f of x equals to 2x minus 1. So f of 5 equals to 2 times 5 minus 1. F of 5 equals to 9. I will go ahead and try these next two problems before I go over them. F of 0, since 0 is less than 3, we're going to be using, and this is where x is equal to 0. Since 0 is less than 3, we're going to be using our star function, and that's f of x equals to x plus 5. So if I want f of 0, that's equal to 0 plus 5. F of 0 is just equal to 5. And f of 3. F of 3 is less than or equal to 3. So for this one, when we're using x equals to 3, we are still using the star function. Okay, which is f of x equals to x plus 5. That's f of 3 equals to x plus 5. So f of 3 is equal to positive 8. All right, for these next ones, let's really quickly just go over them. Open up our calculator. What buttons do we press to get the absolute value symbol? First, we're going to press math. Okay, and then we're going to press the right arrow key. Whoops, right arrow. So you're looking at the key that looks like this. To go over to number, and then the first one says absolute. So you're going to hit enter, 1, absolute, and you get these symbols. Okay? What buttons do you press to get the square root? You're going to press second, and then you're going to press the x squared button, because on top of the x squared button is the blue symbol for square root. And then last but not least, how do you get the cube root? Most people were really confused with this one. Again, we're going to start off by pressing math. And then you're going to go down to number 4, cube root. And that's it. 5, a lot of people thought it was 5. 5 gives you any root that you want, right? So I can put in 3. I can't delete it. I can put in 5, I can put in any root, but if I wanted the cube root, you can do that. All right, that's all for today. If you have any questions, again, please feel free to ask them in class. Leave a comment here, leave a comment on Google Classroom, send me an email, whatever you need help with. Thank you for watching this video. I really appreciate you taking your time to try to do better. Okay, I will see you guys soon. Bye.